In this video, we are going to be discussing question 6.21 in your textbooks. It's the example problem. And I know you'd probably be having a couple of questions related to this particular problem. I did notice that there was a slight error at one particular step, which led to me getting a different answer compared to the textbook. But this is what I got, and this is what I'm going to share. And if you think there is something different that's happening, definitely let me know. This particular question is related to the ionization of weak bases. So the pH of 0.004 molar hydrazine solution is 9.7. We need to calculate the ionization constant and pKb. So let's write down what's given. So pH is equal to 9.7. Since it's bases, it's going to be above 7, right? And then we've been given the initial concentration of hydrazine is equal to 0.004 molar. We need to calculate, oh God, I don't know what's happening to my laptop. I swear. Okay. So we need to calculate Ka and pKa. Okay. So first of all, so let's write down the equation for this. So NH2, hydrazine is NH2 plus H2O is in equilibrium with N, I'm sorry, NH2, NH3 plus OH minus. Okay, so this is the general equation for this particular question. So first of all, we have been given the value of pH. So from the value of pH, we are able to calculate the concentration of H3O plus. Okay, so the concentration of H3O plus, so pH is equal to minus log concentration of H3O plus. And I know I use H plus and H3O plus interchangeably. That's fine. So you have 9.7 is equal to minus log concentration of H3O plus. Now we'll switch this to this side. So we're left with concentration of H3O plus is equal to 10 to the power minus 9.7 because we're taking the anti-log. Okay, now when we take the anti-log, we are getting the value 1.99 into 10 to the power minus 10. I think this is where we're different from the textbook, where they got 1.67 into 10 to the power minus 10. I did double check that, the anti-log of 9.7 minus 9.7 is 1.99 into 10 to the power minus 10. But, we're human. We can make mistakes. Definitely let me know if there is a different answer that you got. So, yeah. But from here on, we will be using the value 1.99 into 10 to the power minus 10. Now, we know that from the ionic product of water, if you remember the value of Kw, so H2O, do you remember this equation? H2O plus H2O gives rise to uh, H3O plus OH minus. So for the ionic product of water, you have Kw is OH minus, concentration of OH minus into concentration of H3O plus. Okay, so we also know that the value of Kw equals to 10 to the power minus 14. Okay, now what we'll do is, we're using this particular equation, we have the concentration of H3O plus, right? And we know it will try to stay, the value of Kw is going to try to stay at 10 to the power minus 14. What we will try to do is change the value of OH minus and H3O plus to get to that. So what we will do is, we are going to be calculating the value of OH minus, the concentration. So the concentration of OH minus is equal to Kw divided by the concentration of H3O plus. Okay, now the concentration of H3O plus or OH Kw is 10. Oh my god, the value of Kw is 10 to the power minus 14, and the concentration of H3O plus is 1.99 into 10 to the power minus 10. Okay, now the reason we haven't used H3O plus is because you obviously have different value, right? It's a different substance, or it's a different ion altogether. If you noticed for our acids, we usually use the pH because we got the ion was H3O plus, but we are talking about bases. Because of that, you cannot directly use this concentration and say, oh yeah, this is the concentration of hydrazine ion. So what we're doing is we're calculating the concentration of OH minus ions. Okay, so the concentration of OH minus is going to be equal to, this on simplification is giving us 0.5025 into 10 to the power minus 4. Okay, so the number of OH minus ions will be equal to that of the hydrazine ions. So this is equal to concentration of NH2 NH3 plus. Okay, now this is because the concentration of OH minus ions and in comparison to that of NH2, that of is equal, and so we have the concentration of NH2 NH3, that is the ion, equals to 0.5025 into 10 to the power minus 4. Okay, now the next thing we are going to do is try to calculate the value of Ka. Oh, I'm sorry, this is Kb. I've been recording videos related to Ka this evening, so I think I just wrote Ka. I'm sorry, it's Kb. So Kb will be equal to concentration NH2 NH3 plus into concentration of OH minus whole divided by concentration of NH2 NH2. So first of all, notice that the concentration of OH minus and this particular ion is super low. So we are going to just assume, and it's a weak acid, so the amount of dissociation that weak base, and the amount of dissociation that would have occurred would be significantly low. And because of that, we can just easily just take in the fact that, the concentration of the hydrazine does not change. So we're going to assume that the concentration of NH2 NH2 stays as 0.04004 molar. Okay, so all we are going to do is substitute the various values. So you have, I'm also going to change this into 5.025 into 10 to the power minus 5. I felt a little bit easier when I was doing the math. So 5.025 into 10 to the power minus 5 into 5.025 into 10 to the power minus 5 whole divided by the concentration of NH2, which is 0.004. Okay, now this we are going to have to simplify. So first of all, you have 5.025 square, excuse me, into 10 to the power minus 10 whole divided by 0.004. So this we can further simplify 25.250 into 10 to the power minus 10 divided by 0.004. Okay, now this is equal to 25.250. Oh my god, sorry. 25.250 into 10 to the power minus 10 divided by 4 into 10 to the power minus 3. Okay, so when we take this 10 to the power minus 3 from the denominator to the numerator, you'll be left with 10 to the power minus 7. So you have 25.250 divided by 4 into 10 to the power minus 7. So this gives us a value of 6.312 into 10 to the power minus 7. Okay, now the last thing we need to do is calculate the value of pKb. pKb is minus log value of Kb. So this is equal to minus log 6.312 into 10 to the power minus 7. Now I've done this simplification so many times. My mouse is missing. Oh, I found it. Um, so this, when simplified further, you get minus taken out in common log 6.312 plus log 10 to the power minus 7, and this is equal to log 6.312 is 0.8001 minus 7, and this is equal to 6.1999. So this is the value of pKb. So what we did, we were asked in this question was we were supposed to find out, we were given the pH as well as the concentration, the initial concentration of hydrazine. We had to figure out pKb and Kb. First of all, we wrote down the dissociation, like the equation for the hydrazine, which gave us NH2 NH3 plus OH minus. Using the value of pH, we were able to calculate the concentration of H3O plus, right? From there, using the ionic product of water, we were able to calculate the OH minus ion. Now, the concentration of OH minus will be equal to that of the NH2 NH3 plus. Okay, so we assume that the number of ions which are coming out from the hydrazine, the concentration of OH minus is equal to that of the hydrazine ion itself. And then we were able to using the formula for Kb, we were able to calculate the value of the Kb, obviously. And then we also assume that the concentration of hydrazine does not change much. Two things. One, it's a weak acid. Second is the fact that the concentration of OH minus and the hydrazine ion is so small. It implies that it's not dissociating to a great extent. Okay, the initial concentration is also super dilute. So because, I mean, it's not very dilute, but it is dilute, right? So because of all of that assumptions, we can easily assume that the concentration of hydrazine itself is staying the same. So from there, we were able to calculate Kb, and then we were also able to calculate pKb is equal to minus log Kb. I hope all of that made sense, and I know, we have gotten a slightly different answer than the textbook. And the next, and then just let me know if you have a better way of doing this, or if if you found this helpful. So in the next video, we will be talking about question number 6.22.